So stats class, here is the chart for the second half of chapter 10. And I'm recording it since it's a basic day, but you could also come hear me do it live, of course. This is 10-2B for confidence intervals and 10-2C for significance tests. And I just gave away the first two answers, but that's okay. So on both of these, you have to name the parameter, and reminder that in this chapter, our parameter is a difference. So mu1 minus mu2, not x bar because we want the population, is the difference in the mean, some kind of measurement that you made on your population. And you have two different populations, so you need to name them both. So when I say measurement, I mean like it might be the mean test score or the mean growth of a plant or whatever it is you're measuring about your population. And you have to name the confidence level if you're doing a confidence interval, which is called C. And if you're doing a hypothesis test, you do the significance level, which is called alpha. If you're doing a confidence interval, you can leave out the hypotheses. And if you're doing a test, you need hypotheses. So this one would be mu1 equals mu2, or you could write it in this form with the mu1 minus mu2 equals 0. And the alternate, of course, could be either a not equals or a greater than or a less than. And same thing over here, mu1 minus mu2 might be a not equals 0 or a greater than or a less than. This is almost always 0, and the calculator assumes it's 0, doesn't give you a place to type it. So we're focusing on that type because usually the null is the dull that there's no difference. The null is no difference, and the alternate is there is a difference. And maybe you know which way that goes, and maybe you don't. So the formal name for these things, which you're supposed to include in the plan, is a 2-sample t-interval or a 2-sample t-test for a difference of two means. You can abbreviate a little bit as long as you have the word interval or test and the word difference and the word mean in there somewhere, because we have learned how to do difference of two proportions and a bunch of others, right? This is, I'm starting to lose count, but I think this is like I'm going to say chapter 8 had 2 things, chapter 9 had 3, so that's 5, so 6, 7, 8. This is number 8 and 9, I think, of our list of types of procedures we know how to do. Kind of crazy. All right, so conditions are the same for our confidence intervals and for tests, which is kind of nice. We can just write it once. Random could be either a random sample, 2 random samples, or it could be randomly assigned treatments. Randomly assigned treatments is actually pretty common in this chapter. And you check to see if that's given or not. N is for normal. And this is where you don't check NP anymore. You check the N1 and the N2 to see if they're bigger than 30. That's one way to check. Or populations are approximately normal. And that could be given, or you could check the graphs. And it's okay to check the graph on one of them, and the other one you don't have to because it's bigger than 30, or one of them might be given. Check them separately. And then remember that this 30 thing, really it's a 15-30. Don't forget the 15-30 rule. If it is between 15 and 30, then a little bit of skew is okay. And if it's under 15, then we really need it to be symmetric. So that's a rule for how picky we need to be about those graphs that we're looking at. Independent is the same thing that we've done, except there's 3 things now. We have to have 2 separate independent samples. and N1 and N2 both have to be less than 10% of their population size. Or if it's an experiment, you don't even have to check this because the randomly assigned treatments would work for that. So randomly assigned treatments kind of takes over and trumps all of this, all the rest of this checking of independence. You don't have to worry about it with experiments. So formulas are really important. As I've told you before, if you forget the name, then if you have the right formula, we'll forgive you for that. Both I will and the AP readers will. If you don't have the right formula either, then you've lost some points for not having the right procedure. So the calculations for a confidence interval are x1 bar minus x2 bar plus or minus t star and S1 squared over N1 and S2 squared over N2. We are not pooling for either one of these. So your calculator is going to ask you if you want to pool or not. It's called the two sample T-int on the calculator. And when the calculator says pool, just say no, don't pool. And this T star is based on the DF that the calculator does. Calculator DF from the calculator is the long ugly formula, or you could do the conservative approach, which is the smaller n minus 1. If you're doing the conservative approach, you have to type all of this in your calculator. And to get your interval, you can't use the short. Well, obviously you'd be doing that because you didn't have the shortcut, and that would be fine. So if you don't have the shortcut, do it with the smaller n minus 1 of whichever n1 or n2 is smaller. Test statistic, if you're doing a test, would be t equals, and we have our x1 bar minus x2 bar again. Notice these are always the same. That's our sample statistic. This is minus 0. This is the same standard error as for confidence intervals. So here's something that's different from proportions. With proportions, we have different calculations depending on which one it is. With means, we just do the same thing. So no worrying about pooling on there. Pooled, we only pool if standard deviation 1 equals standard deviation 2, and it's usually not true, or we usually don't know it, so we're just not going to pool. So that same thing happens over here. In graduate school, they made us test for this to see if it was true or not, and then pool if it was. We're not doing that. The DF is found by the calculator, if you're lucky enough to have that kind, or you could do the small n minus 1, smaller of the two n's. And the p value, the calculator would do that for you also, but if you're doing it by hand, it's TCDF of T and 999 and DF, and you'd only do that if you had to. I mean, you could use the calculator, let the calculator find DF for you and then do this, I guess. That would be for if it's greater than. If it's less than, you would do negative 999 and T and DF and double for not equals, but you mostly aren't going to worry about this because the calculator shortcut is awesome. I would say just write the formula out and then use the calculator shortcut. Two sample t-test. So in this particular part of the chapter, lesson 10.2, I strongly recommend you use that calculator shortcut if you have it and don't mess with the long ugly DF formula. Interpretation, you should be getting really good at these. I hope I'm writing them down one more time just to be sure. So we are C% confident that the interval from the low number to the high number contains or captures the true difference in means of context. And remember, the context should include what you're measuring, like we said at the top, and both populations. And then over here, we're going to, if P is small, we're going to reject the null. If P is large, we're going to not reject the null. Don't say accept, just say do not reject, or some people say fail to reject. You always include your justification, decision, and context. And if you're following my sample sentences that I have here, you will always get those three things anyway, but those are the things they checked for on the AP test. So justification is since P equals, put the number, compare it to alpha. That's your justification. We reject or don't. The null hypothesis, that, and here's where you put it in context. And your context should include both populations and the thing you're measuring. And then the last sentence is about the alternate. We either have or don't have evidence that the null is true, and that would also be in context. I suppose you could leave off the context on one of them if you had it on the other one. So it's always a good idea to state that alternate in context as your last little bit of your sentence. And then sometimes you are asked to interpret the confidence level or the p-value, and those could still keep showing up on quizzes. You never know when they're going to show up. So if you're interpreting the confidence level, it is C% of all intervals will capture the true difference in means of whatever our context is. We learned that way back at the beginning of chapter 8, but it still keeps showing up once in a while. And then this is a p% chance. P-value is the chance of getting our, in this case, it's our difference or more extreme. Or more extreme, which could be a greater than or less than. Actually, it'd be a greater difference. I'm going to just say or. This is almost always greater, a greater difference than 0, if the null is true, which is usually that the true difference equals 0. All right, so there's your chart. I will put a picture of this on Canvas, and if you ask me nicely, I'll do it again live in class.